If you were to look through this prism, you would see that light that looks white is actually made up of many different colors, the colors of the rainbow. Each color can be thought of as a light wave with a different wavelength, or size. Small range of wavelengths that we can see with our eyes, the shorter ones are blue, and the longer ones are red. Colors such as green, orange, and yellow are in between the blue and red ends of the visible spectrum. When light comes from the sun, all these light waves of different wavelengths travel through empty space. When they reach Earth's atmosphere, the light waves can interact with particles in the air, such as dust, water droplets, or ice crystals. Because of the extremely small size of visible light waves, these light waves also interact with the tiny gas particles that make up the air itself. The light waves bounce off these particles. As they bounce off the particles in many different directions, we say that these light waves have been scattered. How light waves get scattered depends strongly on the size of the particle compared to the wavelength of the light. Particles that are small compared to the light wavelength scatter blue light more strongly than red light. Because of this, the tiny gas molecules that make up Earth's atmosphere, mostly nitrogen and oxygen, will scatter the blue portion of sunlight in all directions, creating an effect we see as the blue sky. Within the visible range of light, red wavelengths are scattered the least by atmospheric gas molecules. So at sunrise and sunset, when the sunlight has traveled a long way through the atmosphere to reach our eyes, most of the blue light has been removed, leaving mainly red and yellow light remaining. The result is that the sunlight takes on an orange or red cast, which we see reflected from the clouds and other objects as a colorful sunset. Small particles of dust or pollution in the air can contribute to or even enhance these colors. But the primary cause of a blue sky and red sunsets is the scattering by the gas molecules that make up our atmosphere.